Hey guys, today let's see about AWS. Okay, so actually I've created this DevOps Docs GitHub page. So here all the notes for each and every tool I've set up. Okay, so today we can see AWS. Okay, so AWS is one of the cloud providers. Okay, so what exactly is cloud computing? Cloud computing, it is like a infrastructure which is provided by some providers which we use for ourselves. Okay, so you have to deploy the application. Okay, you have to deploy the application. So what you have to do, the application has to be set up on a server. Okay, you have this server. Okay, let's consider this as server. So first thing is you have to purchase the hardware. So this is your office, this is your office B. Here you have to set up the server. Okay, if you have to set up the server, first you have to get hardware. Okay, you have to get hardware like RAM, CPU, and then you have to get operating systems, everything, and then you have to set up networking, and then everything you have to configure. Okay, so once you configure, the server is ready, and then you are deploying your application. Okay, so it's good, it is running fine. Okay, now what happens, like it runs smooth for 6 months. It runs smooth for 6 months. Then after 6 months, initially the traffic which is coming, for example, if initially for 6 months, like let's assume like 1 lakh users, 1 lakh users are accessing it. It is working fine, it is serving the traffic. So 1 lakh users are accessing, so they are provided with the data. Then all of a sudden what happens, for example, uh, some viral content has come in your application, and then all of a sudden like 10 lakh users, okay, 10 lakh users started accessing your server. Okay, after 6 months, so what happened, this server it will start degrading. Okay, it will start degrading. Why? It is not able to handle the capacity of 10,000 users. Then what you have to do, you have to like in case if 10 lakh users are accessing your application, then actually it is a good news. But what is happening, your servers are not able to compensate the amount of traffic which is coming. So then what you have to do, actually, then you have to increase everything. Like you have to increase hardware, like you have to create a new server or something. You have to increase RAM capacity, you have to increase the CPU, you have to get a new operating system. Again you have to like create new network, and then this time you have two servers, right? Now you have configured two servers. Okay, and then we have to enable the load balancer as well between them. And then to persist the data, you have to create database. Okay, you have to get another database server, because the data, like users, they are logging in, right? Like for example, let's consider this as Amazon. So in case if you're logging to Amazon, even if you log in after 6 months, you can use your login ID and password, and then you can log in. So all those data, it will be saved in databases, right? So you have to create databases, and then everything has to be configured. So uh, 10 lakh users has come. Now you are managing two servers, it is fine. On some day, some 20 lakh users came. Okay, so 20 lakh users came. Then again you have to set up everything. Okay, you have to set up all the servers, everything, networking, RAM, CPU, operating system, everything has to be done. And what happens, this complexity, it will keep on increasing. For example, let's consider you have like 500 employees in your organization. And let's consider organizations like IBM, Accenture, and Capgemini, whatever it is, they have employees in lakhs. Okay, so when you are managing these things for lakhs of users, then actually like you need bigger servers. Okay, for example, if you are like a reputed organization, and if you have all the budget, then it's fine. You can create your own infra. You can create your own infra, and then you can purchase whatever it is. Okay, and also the thing is, you have the money. Okay, you have the money, but the thing is, in case if you are ordering the hardware, okay, it will not be delivered within seconds. Okay, it will not be delivered within seconds. To get the hardware, it will take weeks. Okay, it will take weeks, or else in some cases it will take months. Okay, and then in case if you have to increase the RAM, then again there will be downtime. There will be downtime in particular server, because you have to turn off, and then you have to upgrade the hardware, right? and then setting up these environments, and then everything is so complex. In case of some issue happens in the environment, okay, if some issue happens in the environment, again we have to assign a separate engineer for this one. We have to assign a separate engineer. What this guy will do, he will go to the infrastructure, and then he will log in, and then he will just check like which server is having issue, and then he will be fixing that hardware issues. In case if some network issue happens, okay, so this guy again is, he has to go, he have to check which network is having issue, and then he have to fix. And then okay, what happens, and the main thing is like, you are having the infra, and then as you have like hundreds of servers, you have hundreds of servers. So if you have hundreds of servers, it will produce lots of heat, okay, it will produce lots of heat, okay. And then what happens, and then in case if you are it is producing lots of heat, then what you have to do, you have to install the air conditioner, okay. So for air conditioner you have to spend a separate amount. So this is like big infra, it is of 100 acres, right? For 100 acres, if you have to install air conditioner, how much it will cost, okay. And then you have to maintain electricity, okay, you have to maintain electricity, because if there is power down, if there is power down, all the servers it will crash, okay, all the servers will go down, right? So you have to have like electricity 24 bar 7. In case if electricity goes down, you should have the power backup, okay, you should have the power backup, okay. So the power backup it will cost too much again, okay. And then there will be maintenance for this power backup. You will be requiring diesel or petrol to run this power backup, and then again it will be costly. And then again, in case if you are using some solars for power generation, again it will cost you, okay. And then okay, you have everything and it is fine. But what happens, like in case if some natural disaster has happened, like some earthquake or floods or something has come, and then this facility which is at particular location, it is affected by that earthquake or flood, then what happens, again even though you have facilitated everything, like you have hundreds of servers, you have networking, you have installed air coolers, and then you have power backup, everything, but due to earthquake or else due to some other thing, again the flood, it was flooded or it was destroyed due to earthquake or some natural calamities, okay. Then what happens, again everything is gone, all your applications will be gone, your customers will be impacted, everything will happen. So what happens, so let's consider this example. So one facility is not enough, okay. So let's consider India. So here let's consider you have one facility which is currently at Delhi. Okay, it is at Delhi. So if something happens at Delhi, then it will be totally affected and you will not be able to access any services. So what you have to do, you have to create another facility at some other location. Let's consider Hyderabad. Okay, so you are creating another facility here. Okay, so that what happens, the data should be synced between this thing, and you can place your application uh, application A1 here, and then another application A1 here, okay, so that you can have two applications. Even if one goes down, you can have another another place, okay, you can have it in another place so that it will serve the traffic, okay, that is fine, okay. In case if your organization is very big and they have all the budget, they can do, okay. But let's assume a startup, okay, you are trying to build a startup, you're trying to build a startup, okay. So like for managing one infra, for managing one infra, it may cost like 100 crores, okay. In to manage two infras, it will cost 200 crores. But will startups have that much money to create their own infras? No, right? So what they can do, in case they are building some application, they just need a few EC2 instances, okay, few EC2 instances, few DBs, and then networking VPC. Okay, let's assume like they use only three services. When they use only three services, they will tell like to create their own infra, it will cost 100 CR. Okay, but they want only three services: EC2, DB, and VPC. Okay, so it will cost like some 50,000 or 1 lakh. Let's consider it will cost 1 lakh per month. Okay, so when considering 1 lakh with 100 crore, it is very cheap, right? So what they will do? They will go for infra services. Like in case if someone is providing something on rent, they will go for that one. They're ready, they can spend 1 lakh per month easily instead of spending 10 crores or 100 crores on that. So similarly, what happened, there are few cloud providers. Okay, so there are top cloud providers like AWS, from Amazon. Okay, and then from Microsoft, some Microsoft we have Azure. Okay, and from Google we have Google Cloud. Okay, and then we have from IBM we have IBM Cloud. Okay, and then we have Alibaba Cloud, and then Oracle Cloud. Okay, so what are all these? So they are all cloud providers. Okay, they provide the service. Like they have the infra, for 100 crores. Okay, they have the infra for 100 crores and 200 crores. Okay, so they have this infra, so they are doing this as a business. Okay, so they will provide their infra. Okay, they have the infra, they provide their infra on rent for these guys. Okay, so they will be paying 1 lakh per month to this AWS, and they will provide the EC2, DB, and VPC. Okay, similarly we have Azure, so even they provide their infra on rent. Similarly, we have Google Cloud, they provide it on rent, and then we pay the rent, and for the services which we use. By that, they will earn money. Okay, they will earn money, and then we will be paying money. So we will be paying less money. Similarly, they will have like hundreds of customers. Okay, they will have hundreds of customers, and then we no need of worrying about anything. Okay, even power goes down, or else maintaining air coolers, and then we have configured the infra, right? So we have configured the infra. So for this infra, like we can't allow anyone, we should have security guards. Okay, we should have security guards, and then in case if someone has to go inside, they have to get all the passes, approvals, everything. Because if someone goes inside and if something is done, then actually it will affect the servers, right? So it will be highly secured. Okay, it will be highly secured. So you have to manage the security in case if hardware goes down. Everything will be taken care by these service providers. The AWS will take care of all the network issues, cloud issues, like in case if network down or security, personal security, whatever it is, AWS will take care. You just take the service which is required, and then you pay the money based on the amount of time you use that service. Okay, so this is how the cloud providers are working. Okay, so what exactly is cloud computing? It delivers the computing service. Okay, it delivers the computing service. So what are the services? It provides servers, storage, databases, networking, software. So they provide everything. Okay, so they will charge you based on the usage. Okay, over the internet. So how you will be able to access that one? You will be able to access it over internet. Okay, so what are the key characteristics? Okay, and then I have told you, right, in case if you have to create the hardware, it may take months. Okay, sometimes it will take weeks, sometimes it will take months. Okay, but in case if you are just using the service, within seconds, within like 1 minute, you will be able to create a VM. No need of worrying about hardware import, like exporting, importing, and then assigning an engineer to configure that one. To configure itself, it will take like weeks or months, and then to purchase that hardware, it will take months. So you can avoid everything. If you need an EC2 instance, it will just take like 1 or 2 minutes. Okay, within 1 or 2 minutes, your server will be up and running. Okay, so that is the advantage of these cloud providers. Okay, so what are the key characteristics? So on-demand self-service. Okay, whatever resource you want, you can get it. You no need of, like in case if you have an AWS account, we have different providers, right? You just create an account, okay, with them, and then no need of discussing with anyone. In case if you need a EC2, you can directly go to the console, click on EC2, and then EC2 will be up and ready. So what is that? On-demand self-service. Resources can be provisioned without human interaction. No need of human interaction. Okay, and then broad network access, like it will be available over internet, and it is easy to access. And then resource pooling, like we have the infra, and then any customer, like they will have hundreds of customers, so everyone will be able to access their service. And then elasticity, in case if you want 100 servers, 100 VMs, you can create 100 VMs. In case if you want only 10 VMs, you can delete 90 VMs and you can keep only 10 VMs. So we have the elasticity. And measured service, like pay as you go pricing, like in case if you are using, you pay, otherwise you no need of paying anything. Okay, so what are the key benefits of computing? Cost efficiency. So instead of spending hundreds of crores, you can just complete whatever you need with 1 lakh. Okay, that is like cost efficiency. Scalability. In case if you need 100 servers in 2 minutes, you can create. It is flexible and mobility. So you can flexibly use whatever it is. And security enhancements, like it is highly secured. Like you can create your own VPCs, everything, and it is like highly secured. Okay, and then we have different types of cloud models. Okay, we have public cloud, private cloud, and hybrid cloud. What are the main difference? Public cloud is nothing but public cloud providers like AWS, Azure, and GCP. So they are public cloud providers. Private cloud is nothing but I create my own infra. I told, right, we create our own infra and then we use it. So that is called private cloud. Okay, and then hybrid cloud is nothing but in case if you are using, instead of using only one cloud, AWS, we can take few services from AWS, few services from Azure, and few services from cloud. Because let's consider EC2. Okay, let's consider this EC2 as the example. Okay, so AWS is providing the EC2 for $2. Okay, and then Azure is providing for $3, and GCP is providing for $4. Okay, and then we have storage. Okay, storage, AWS is providing for $4. Okay, and then in case if you take Azure, they're providing for $3, and GCP they're providing for $2. Okay, now in case if I take EC2 from AWS and then storage also from AWS, how much it will cost me? It will cost me $6. Okay, and then I take EC2 from Azure, and then I take AWS from like storage from Azure, then it will cost $6. Okay, but what I do, I take EC2 from AWS. For how much? For $2. Plus I take storage from GCP. How much? $2. So how much it costed me? It costed me $4. So I am saving $2. So I am giving simple example. Okay, in case if it is costing $2,000 and then it is costing $4,000, then which is better to use? The one which is providing for low cost, right? So when you have hybrid cloud, you can choose one service from one cloud provider and another service from another cloud provider. Okay, that is called hybrid cloud. Okay, or else in case if you have your own private cloud, then just the services which are required, for example banks. Okay, what exactly banks does, right? So they take all this EC2 and then other things from cloud providers like AWS or Azure. Okay, but DBs, like they have their own servers. Okay, they have their own servers in private cloud. Okay, so they use public like AWS or something plus private, their own DBs. So this is called hybrid. Because for banks and all, data is more important, right? Like our account details, like credit, debit histories, everything. So they don't want that to be in cloud. So they want to have their content only in their own servers. So then what they can use? They can use their own private clouds. So this is called hybrid cloud. Okay, and then we have service models. Okay, what are the service models? Infrastructure as service. So infrastructure as service means, so let's consider this one. So we have this infra, so we have a server. Okay, so what this, let's consider this as AWS. So you are a company B. Okay, you want server. Okay, you come here and then take this service, you take this server. Okay, they give it to you. Okay, but they will not manage your application. So you have code, like code means application, and then you have to create EC2, you have to create VPC, you have to create DB, and then in case of any issue in EC2, you have to troubleshoot. In case of any issue in VPC, you have to troubleshoot. In case of any issue in DB, you have to troubleshoot. They just give the server, okay, they just give the server, but the application which is deployed, and then the instances and resources which you create, they will not manage, okay, you have to manage them. In case of any issue in the service provision, then you can contact them. Apart from that, create in issues in EC2, VPC, DB and all, you have to take care. That is called infrastructure as service. So they provide the infra, you have to manage it, okay. And then we have something called platform as service. So what is the platform as service? So they provide the platform, okay. They provide the platform like EC2, VPC, DB, they take care, okay, they take care, okay. But the code which is deployed on that particular machine, it has to be taken care by you, okay. So we have some examples like AWS Elastic Beanstalk and Azure App Services, okay. So they will provide the platform, but deploying the applications and all, you have to take care, okay. And then we have another model called SaaS. SaaS means software as service. So what exactly happens? So they provide all the softwares, even the softwares are provided by them, just you have to configure and use, okay. Example is Gmail, okay. What you do, you just use your username, password, login, that's it. In for Gmail, what exactly happens? You have Gmail, okay, you have Gmail. So the Gmail is hosted on one server, okay. So it has storage, because if you see by default Gmail you will have like 5 GB or 10 GB storage, right? 5 or 10 GB storage. So you have storage, okay. So all these things is managed by AWS. What you do when you have to log into Gmail, you give email ID, and then password. You just give these two. Is there anything like you have to download, you have to configure anything? Nothing is there, right? So this is called SaaS. So similarly, they just give the tool, you have to just log in and you can use. That's it. So this is called software as the service, okay. And then top cloud providers. So Amazon Web Services, Microsoft Azure, Google Cloud, IBM Cloud, Oracle Cloud. So we have all this, but the leader is AWS, because almost like 50 to 60% of customers use AWS. Okay, and then next it is led by Microsoft Azure. Okay, and then AWS. Okay, AWS is the most popular cloud, and then we have different services. Okay, compute. So what is compute? Okay, let's log into AWS console. Okay, this is the AWS console. So if you see, we have this, right? So if you come here, so we have all this like analytics, application integration, blockchain, business application, cloud, finance, compute, containers, customer enablement, databases. So all these are the features which are provided by AWS. So AWS has the large number of services. Okay, now let's take a compute. Okay, if you click on compute, so inside compute we have all this AWS app runner, batch, EC2, global view, elastic beanstalk, lambda. So all these are the services. So we have EC2. EC2 is nothing but the virtual machines. So if you click here, we will have the page open, and then we can select instances and we can launch. Okay, so inside compute we have EC2, lambda, elastic beanstalk. So still we have like many services, just given sample. Okay, so under compute we have these many. Okay, we have these many. So I have just taken a few examples. So EC2 are virtual servers. Lambda is nothing but serverless compute. So you can just have the code. Backend servers will be managed by AWS. Okay, and then we have elastic bean service. So this is like platform as a service. Okay, so you can just configure it and you can use. And then storage. in storage we have S3. S3 is nothing but simple storage service. So yes, right? So because of three S's, they have given it as S3. Okay, simple storage service. So it is a object storage. What is object storage? So you can store images, movies, videos, whatever it is, whatever data you want, you can store in S3. And then we have EBS. EBS nothing but elastic block storage. So in case if you have to add any storage to EC2 instances, it is just like a hard drive. Okay, in case of your laptop, you have the hard disk, right? Similarly, in case if you have to add any additional hard disk to EC2, you can use elastic block storage. Okay, and then we have something called glacier. So for example, you have some data, and that data, for example, last 1 year data you are using frequently. Okay, so in case if you are using frequently, you can keep it in S3 or EBS, whatever it is you can keep. But for example, you have some 10 years old data, but you are using once in a year, that's it, but you are not using frequently, or else you are using once in 2 years. So what you can do, instead of storing it in S3, you can move it to Glacier. Okay. So what happens for S3 buckets, in case if they are charging $1 per hour, for Glacier they will charge only $1 per month. Okay. So it is so cheap. So the data which you are not using frequently, you can move those to Glacier. Okay. And then databases. So databases are that we have RDS. RDS nothing but relational database. So this is a managed relational database. So this is totally managed by AWS. Okay, you can just configure and use it in your applications. No need of managing anything. Okay, this is a SQL database. So what is the difference between SQL and NoSQL? So SQL is like, for example, if you have certain structure like structured queries, then it is a SQL. And for SQL databases, let's consider Oracle, MySQL. So everything is SQL databases. And then DynamoDB. DynamoDB, it is like NoSQL database. NoSQL means you will have like random data. For example, you are configuring ITO, IoTs. IoT is right, like sensor data, everything. So that will be random data and like illogical data, right? So for that you can use NoSQL databases. So NoSQL databases are like MongoDB. Those things are NoSQL databases. And then we have something called Redshift. Okay, Redshift is nothing but in case if you have to process a huge amount of data, like a petabyte types of data, then you can use Redshift. Peta Petabyte means actually it is like hundreds of thousands GBs, TBs of data, not GB, TB. Like 1000 TB of data is called a petabyte. So in case if you have to handle such huge data, then you can use Redshift. Okay, and then we have networking. So in networking, we have VPC, Virtual Private Cloud. So okay, you have the infra. So you have the infra, and then you have two applications. Okay, app 1 and app 2. Okay, and it is used by like a dev team, and then it is used by testing team. Let's assume for example, so we are creating two VPCs. Okay, this is like our infra. Okay, and then this is VPC1, VPC2. So this app 1 is deployed here and app 2 is deployed here. So in case if we need isolation means we can create our own EC2 instances, DBs, and then we can create our own network. We can create our own IPs, route tables, internet gateways, everything can be configured. Okay, so this will be isolated. So this is an infra. Once we create VPC, this itself it will act as a separate infra. It will consider itself as an infra, and it will create all its infra, like all its components. Similarly VPC2, so it can create its own components, so that these two will be isolated. Okay, these two will be isolated, it will not have any connection. So similarly, if you have like two applications which no need of talking to each other, then we can configure like this. Then you can deploy the applications based on the requirement. So we will be using VPCs. So VPC is nothing but like isolated networking. And then Route 53. So for managing the domain names, we can use Route 53. Okay, so domain names like DNS, domain naming system. So what is domain naming system? So for example, we know www.google.com, okay, and then amazon.com, flipkart.com. So we are able to remember it, right? Very easy. Google.com, Amazon.com, Flipkart.com. It is very easy, right? But actually, this is called domain names. Okay, this is called domain names. So what is the actual? Because this is just for our understanding. Will machines, like machines means computers. Computers will not understand this thing. Okay, what computers will understand? Computers will understand only ones and zeros. It understands only two. This is called binary. So it will understand only ones and zeros. So let's consider this one. Okay. In case of google.com, what it will have IP address. For example, let's consider 169.13.1.2. For Amazon, it will be like 141.2.100.3. For Flipkart, it will be like 92.100.3.56. So something, some random number will be there. Will we be able to remember these things? No, right? So as human memory is concerned, we will not be able to remember these numbers. In case of like domain names, we can easily remember, right? So they have configured the domains for each and every IP. Okay. So what you can do, you can just access this. Any of the sites using this domain name. So how we can configure those things? We can configure those things using Route 53. Okay, and then we have CloudFront. Okay, CloudFront is like content delivery network. So let's assume content delivery network is that um, you have Amazon Prime Video. Okay, Amazon Prime. So where exactly this Amazon Prime is there? It is in USA. Okay, so it is in USA, but you have to access it from India. You have to access it from India. So it is like thousands of kilometers, thousands of kilometers far, right? So for data to travel for thousands of kilometers, it will take hours, or else let's take it will take minutes. It has to stream, right? It has to stream continuously. So that is not possible. So then what you can do? Then you can configure a CDN, content delivery network. What happens? So initially the data, Amazon Prime data, it is in USA. Okay, that's fine. What happens once the data comes to India? It will do cache here. Cache. Cache means it will create temporary memory here. Okay. So for example, we have one video, like some random video. We have video. So that video it will be cached here. So for users in India, instead of going to USA system and accessing it, they can directly access this one. It is in India only. So it will be very faster, right? So we configure CDN, that is called content delivery network. So for that one, we use CloudFront. Okay. And then security. For security, we have IAM, Identity Access Management. So to create users and then give permissions and all, we use IAM. And then cloud trial. What is the use of cloud trial? So whatever activity you do, like you create a user instance, you delete it, you create a network, you delete it, you give some permission to a user, whatever you do, all those activities will be captured in cloud trial. Okay. So it is very useful for auditing. In case if someone deletes unknowingly something, in case if you want to find like who exactly deleted that one, you will have the details in cloud trial. Okay. And then AWS shield is like a security for AWS components. So it prevents from DDoS protection. So what is DDoS protection? DDoS is nothing but denial of service. Okay. So for example, you are having an application. Okay, let's assume Amazon. Okay, let's assume Amazon, and let's assume like it is capable of handling 10,000 requests. It is capable of handling 10,000 requests. It is for just imaginary. Okay, so what happens? We have one hacker. Okay, we have one hacker. That guy, what he does, he tries to do DDoS attack. DDoS attack on it. So what he does, he sends 1 lakh 1 lakh requests to this Amazon site. So what happens to this Amazon site? It will be unresponsive. It will be unresponsive, and even for these are genuine users. So these are genuine users. When they try to access, it will come, it will throw some error, or else it will take for loading web page, it may take like 3 or 5 minutes, whatever it is, because of all this latency, everything. So in case if they are trying to do all these attacks, this will be prevented by AWS shield. Okay, so all these DDoS attacks from these hackers will be prevented using this AWS shield. Okay, and then monitoring. So to monitor the all the applications, so no matter whatever the application is, like EC2, VPC, Route 53, whatever it is, to monitor those things, you can configure CloudWatch. Okay, and then cloud formation. Cloud formation is nothing but it is like infrastructure as code, just like Terraform. We can see this later. And then we have something called AWS global infrastructure. So we have regions. Okay, so regions are nothing but geographical areas where AWS has data centers. Okay, we have talked about the data centers, right? Infrastructures. So those are called data centers. Okay, so what exactly is data centers? So let's consider India as example. So let's consider India. So what happens? uh, so uh, so we have region. Okay, we have region, we have region, we have region. So let's consider this as okay, this north, south, west, yeah, which is east, which is okay, whatever it is, east, west. Okay, so let's consider this one. So all these are regions. Okay, so for example, if some calamity like flood or earthquake, whatever it is happened in this south, north is safe, right? So in case if you have your app here, for example, you have your app here, you have your app here also. So even if something happens here, at least this can provide service to the users. In case if you have users, instead of accessing here, the service will be provided from here. Okay, similarly we can have different regions. So these are like, this is called regions. Okay, for example, let's consider this as um, AP South. Okay, this is AP South. Okay, this is AP East, and then this is AP North. So these are regions. Okay, understood, right? So we have something called availability zones. So we have regions in south. There is nothing mandatory called we should have only one infra. Okay, we can have two infras, or else we can have three infras. For example, we can have one in Hyderabad, one in Bangalore, one in Chennai. So these are called AZ. So what is AZ? Availability zone. Okay, so you can place your app, like we have the app, right? You can place your app here, app 1, app 2, app 3. Okay, so it will be served from three regions. Okay, similarly in north you can have three or four, whatever it is. Okay, so now we can call it as AP South 1 A, AP South 1 B, AP South 1 C. Similarly, AP North 1 A, AP North 1 B, AP North 1 C. Similarly, you can have any infras. Okay, so, these is called availability zones. And then we have something called edge location. So edge location is nothing but similar to CloudFront we have talked here, right? So instead of having accessing servers from the far distance, we can have the edge servers close to the customers. So for example, we will know, like for example, lots of users are trying to access from Bangalore. Then what you can do, you can place a edge server near Bangalore. Then what happens, it will sync all the data from north, east, west, everything, and then it will have the data. So in case if users are trying to access this one, they will be accessible very easily. Okay, So this is called edge servers. Okay, just remember region is like north, east, west, south. Okay, availability zones like regions inside, zones inside regions. Okay, we can have multiple availability zones. Okay, and then what are the key features of AWS? Scalability, elasticity, we have security like securing from DDoS attacks, everything. And then for compliance, we can use cloud trial. Scalability, you can have load balancers. We can create any number of EC2 instances. And then cost effectiveness, you can just pay for whatever you are using. And then a broad ecosystem, like you can have third party integrations, everything with AWS. Okay, so where AWS will be used to hosting your websites, and then big data analytics in AI, ML, backup and disaster recovery, IoT applications. So whatever you want, you can use in those things. So this is the intro for AWS and cloud computing. Um, okay, thank you guys.